Hi, I'm Craig Lanzoni, Director of Linear Learning Company, and welcome to this segment of Prep. In this segment, we're talking about one of the three methods that you'll learn to turn SAT algebra problems into arithmetic. Today's topic is plugging in the answer choices, or PITA for short. When do we PITA? When do we plug in the answer choices? First, when there are variables in the question and numbers in the answer choices. When you're being asked to calculate fractions or percents. When the question is looking for specific amounts and includes the words what or how many. And lastly, look for opportunities to plug in the answer choices whenever you get the urge to do algebra. We'll be looking at a number of question types that allow us to employ this powerful tool. In the following examples, we're going to see a number of different math concepts that can be attacked using the exact same tool, and that is plugging in the answer choices. Let's see how this works. Let's look at the steps for plugging in our answer choices. First, label your answer column. Then, set up your workspace. Start with answer choice C. If C works, you win. If C doesn't work, eliminate any other answer choices that clearly won't work. And lastly, retest and choose your answer. We're going to see exactly how to apply these steps in the next sample problem. Here's the sample question we're going to use to apply our PITA rules. Before we begin, one thing I want to point out. Every word problem ever written by the SAT is written the same way. They give you information, then more information, then more information, then more information, then finally tell you what you're looking for. If we know what we're looking for, we can apply this information as we receive it and make sense out of it. The good news is, most word problems are read by most students a minimum of 2 times and usually 3. Do it this way, 1, maximum 2 gets the job done. Remember, this is a time test. Do you really have time to read every question 3 times? I don't think so. All right, so we go to the bottom. How many salads were sold that day? Oh, and there we have how many salads were sold that day. We could then jump into the algebra, or we could say, wait a minute, they're helping us out here. 77, 93, 99, or 105. It's one of those numbers. We say, great. So we're going to label this column salads because we now know what we're looking for. And we're told that salads sell for $6.50 each. We're also told there were 209 total things. So if we take 209 minus salads, that will give us drinks, and drinks are $2 each. Let's use C99 and see how we apply this. So we'll take 99 times 650, and we'll end up with 643.50. Next, we take 209 minus 99, and that gives us 110 drinks at $2 a piece, 220 bucks. When we add those together, we get 863.50. We're looking for 836.50. Oh, looks like a little dyslexia has slipped into the game here. 863.50. Too much. If C is too big, D is also too big. We've already eliminated 2 answer choices with no effort at all. Now, we just have to test one of the remaining 2. If B is correct, we win, and if it's incorrect, it's got to be A. But before we do, 863.50, 836.50, those are pretty close together. And you're probably saying to yourself, oh, It's got to be 93. It can't possibly be as small as 77. I'm going to take 93, color in B, and move on. But if you're one of those students who needs to work everything out, let's do that. 93 salads times 650 is going to give us 604.50. 209 minus 93 will give us 116 times $2 is going to be 232. And when we add those together, we're going to get 836.50, exactly what we're looking for, and we're in business. That's how we apply PITA. Plug in the answer choices. It's a whole lot easier than the algebra, but you can do the algebra if you want. But if you do, I'm going to ask you, go back, double check, make sure your numbers work. Let's see what's coming next. In our next examples, we're going to see how 5 different math concepts can be solved using PITA. We'll see absolute value, a system of equations, an equation-based word problem, inequalities, and finally, a graphing problem, all of which can be solved using PITA. Pay attention, because this is going to be a powerful tool in your quiver when it comes to taking on the SAT. Our next example is absolute value. For what value of n is n minus 1, or the absolute value of n minus 1, plus 1 equal to 0? Now we could try to create some kind of algebra here, or we could just say, wait a minute. N is equal to 0, 1, 2, or there is no such value of n. We don't choose D. Anytime they show us a question that says there is no such value of or cannot be determined with the information given, anything like that, we default to that answer by eliminating A, B, and C. So let's get to work. If n is 0, we have the absolute value of 0 minus 1. Well, that's going to be 1. Plus 1 is going to be 2. Definitely not 0. How about the next one? The absolute value of 1 minus 1. Okay, that's 0, but we're adding 1. It's going to be 1. We're looking for 0. No good. And how about C? The absolute value of 2 minus 1 clearly is 1. Plus 1, not going to work. A is gone, B is gone, C is gone. D has to be our answer, and we have defaulted to D. Plugging in the answer choices works for lots of different questions. Let's see what's next on the agenda. Here's a simultaneous equation question, or you guys call them system of equations. And when you look at this, you're probably tempted right away. Ooh, I got to do the algebra. I got to solve for X. I got to solve for Y. No, just wait a minute. What does it say? What is the solution, X, Y, or the XY pair, to the system of equations above? And then they say, wait a minute, Craig, hold on, let us help you. It's either -5 and -2, 3 and -8, 4 and -6, or 9 and -6. One of those pairs works for both equations. Oh, so all I have to do is plug them in and see which works. Yes. Shall we pick the easiest equation first? How about 2y minus x equals -19. Now, the only thing we have to be careful of is making sure that we choose x and y. So let's look at A. 2 times y. 2 times -2, -4. minus x, which is -5. -4 minus -5, we don't have to go any farther, is definitely not -19. Throw away A. How about B? 2 times -8. Oh, -16. Minus x, which is 3. Oh, -16 minus 3, -19. B works. Let's look at C. 2 times y, 2 times -6, -12, minus x, -4, not -19. And how about D? 2 times -6, -12, minus 9, again, not -19. B is our winner. We didn't even have to check both equations. We only had to check one equation and we came up with the right answer. Plugging in the answer choices turns algebra into arithmetic. Use it. Our next problem is an inequality. And notice that the question asks, which of the following numbers is not a solution of the inequality? Now, we can do the same thing. We can solve for x using our inequality, do the algebra, or we can simply say, wait a minute, if x is -1, -2, -3, or -5, one of these is not going to tell a true story about this relationship. So all we're trying to figure out is which one is not true. Let's start at the top with -1. 3 times -1, let's see, 3 times -1, -3, minus 5, well, that would be -8, is greater than or equal to 4 times -1, -4 minus 3. Wait a minute. -3 minus 5, -8 is greater than or equal to -7? No, -8 is less than -7. Guess what? We found the one that doesn't work. A is the winner because it is not a solution of the inequality. We didn't have to worry about solving for x. We didn't have to worry about flipping the sign if we had a negative number. We're good. This is easy. Plugging in the answer choices. Don't you love it? I sure do. Let's see what's next on the agenda. Our next question uses an equation that they've already given us. Notice it's applicable to two questions here, 9 and 10. The only one we're interested in is number 10. They give us an equation. A equals this. We don't know what that means. But here's the thing. Whenever they give us an equation, they will explain to us what the pieces of the equation are. Then it's our job to reason our way through the equation to kind of make sense out of it and then get to work. So let's see what this says. First of all, at which of the following air temperatures will the speed of sound be closest to 1,000 feet per second? Let's go see how we apply this equation. The speed of a sound wave in air depends on the air temperature. Okay, that makes sense. The formula above shows the relationship between A, the speed of sound, all right, so this is going to be our speed, and T, the air temperature in degrees Fahrenheit. Now, when I say we reason our way through this, here's one of the things we ask ourselves. So this says to me, if T is 0, then the speed of sound is 1,052 whatevers. If the temperature goes up, okay, so if temperature is 1, then I'm adding 1.08 to 1052. So if the temperature goes up, the speed goes up. Oh, and if this is a negative temperature, if the temperature goes down, the speed goes down. Makes perfect sense. Now we go here and we're saying, okay, which one of these is going to be closest to 1,000 when I put these numbers in for t? Well, they're telling us. Plug in the answer choices. See which ones work. So let's start with C. Negative 49 degrees times 1.08 is going to be equal to negative 52.92. Add that to 1,052, and we're going to have a speed of 999.08. Now, we've already said, if the temperature goes down, the speed gets slower. So at negative 50 degrees, we would be slower than 999, so we can eliminate that because it takes us away from 1,000. Let's go to 48. 48 times 1.08 is equal to negative 51.84. Add that to 1052, and we get 1000.16. Again, a higher temperature gets us farther away from 1,000, so we can eliminate A. Now the only question is, which one of these is closer to 1,000? It's definitely going to be B. And we're done. Plugging in the answer choices happens lots of different ways during the test. I urge you, become really good at this skill, and it will serve you well for the test. I promise. Our last question for this segment. Oh, I'm down here. Yeah. Hi. I had to move things around because I ran out of space up there. Anyway, our last question is a graph. And we're going to see that these are easy questions. They come in lots of different flavors, but they all are similar. You have an equation you're trying to match to the graph. Let's take a look at the question. Which of the following represents the relationship between H and C? Then we look at this and we go, H, oh, there's H, oh, there's C. Okay, let's say, which one of these represents that? And I'm going to say, stop. Don't try to match the equation to the picture. When you look at this or this or this, you have no idea what that picture looks like. Neither do I. Maybe James Tanton does, but that's about it. But we don't have to figure out which of these matches the picture. We're going to take a number from the picture and we're going to match us. So that's what we do. Take any number from the picture you can see. You can take 1 for time and 8 for cost. I've chosen 2 and 11. Doesn't matter what you pick. So I'm saying H equals 2, total cost, or Y, equals 11. Now we just go to these equations and say, which one tells the truth? How about A? 11 equals 5 times 2, 10. Nope. Close, no cigar. How about B? C equals 3/4 of H. 3/4 of 2 plus 5? Definitely not 11. Throw it away. How about C? 11 equals 3 times H. Ooh, 6 plus 5. 11 equals 11. Perfect. And since we're not making up our own numbers, since we're pulling numbers off the graph, only one of these is going to work. We found it. We're done. Simple, simple, simple. You'll see much more complicated equations attached to much more complicated graphs. Some of them even are scatter plots, but we solve them exactly the same way. Take a number from the graph, bring that number over, see which of these tells the story about your point. Really simple. For now, that's plugging in. I'm going to give you lots more work to do in your resource guide. So those are the essentials, plugging in the answer choices. As you can see, we can use this tool in lots of different ways, in lots of different places, for many, many different kinds of math concepts. This one tool is about 15% of the math section of your test. So be really, really good at it because it's going to serve you very well. Remember, check your resource guide that comes with this video. You'll find a lot more practice questions you can do, and good luck. Thanks for joining me, and I look forward to you joining me in the next segment.